Thanks everybody. So I'm so excited to be here, especially because the last time I was in London was about, 5 years ago, something like that. And I was a teacher, and I was kind of broke, and I was staying in a hostel, and everyone was smelly, and I was really smelly, and you all smell so nice, and I smell better. And so this is much, much better start on the right foot. My computer died this morning, so I'm using a loaner. So if anything weird happens technically, that is part of the joy of presenting live. All right. Okay, so serverless functions and Vue.js. Erica did a really great job this morning kind of covering some of the more abstract things that we talk about when we talk about serverless. And today what I'm doing is doing a little bit more of the practical applications of serverless and digging into how we actually make pair applications with serverless functions. So how many of you can predict the future? Are there any early Apple investors here or like Bitcoin millionaires in the room? Yeah? No? No? Okay, me neither. All right. Well, for the rest of us, when we launch an application, when we finally get it out, this is what success looks like. We jump around in formal wear on a skyline, and we're so excited. But we immediately have to scale our server, right? As soon as we're successful and we launch an app, we realize that we have, oh my God, so much traffic, so many customers, so much to deal with, and that is kind of a bummer. And I think we'd all like to think that during the process of scaling, we look something like this. We've got our dope hoodie on. We're so good at programming because we're like elite, and we've got like our fingers are literally on fire, and smoke is billowing out of our screen, right? But you actually probably look more like this. You're in your sister's hand-me-down rain jacket, and you're trying to find the Q key. And even when you do, you're not sure if you can exit Vim. So what about the more likely scenario? That you didn't exactly fail. It's not like you got no signups, but you didn't get as many signups out of the gate as you were hoping for. And in that case, you're paying for all of this capacity that you're not using. You've got John Travolta in your wallet, which is really awkward to explain to a bunch of VCs. And you can totally scale down, but then you know, what happens if things kick up again, which is like best case scenario? Then you've got to scale up again as well. And scaling is a bit of a drag, which brings us to serverless, which is an actually interesting thing with a terribly clickbaity title. I mean, it's true. Every single person in this room, the first thing they're going to say to anyone who talks about going to this conference is, well, you know, we're still using servers. So why do we call it serverless? Well, the promise of serverless is to spend less time setting up and maintaining a server. So what we're focusing on today is the part of serverless architecture that boils down into functions that say, when this request comes in, run this code. And for this reason, people often call them FAS, or functions as a service. I'm Sarah Drasner, known on Twitter as Sarah Edo, and I work for Microsoft. Yeah. I'm also on the Vue core team and a staff writer for CSS Tricks. And I'm here today to talk to you about how you can integrate something like serverless functions in a very practical way with something like a Vue.js application. So some of the benefits of serverless functions include some of the things that we kind of mentioned before. You pay for only what you're using, which is usually a lot less. And this is kind of like an industry secret, is that really you're actually paying way low than you should. We started all of the service providers started competing at like way low of a rate, and now they have to keep competing. So it's actually kind of inappropriately priced for the consumer, which makes serverless a really kind of compelling thing for all of us developers to dig into. There we go. We also spend less time setting up and babysitting a server. That is a huge part of serverless functions, is that it auto-scales, and we don't have to worry about doing all of that manual adjustment. And something that I quite like about it, because I like functional programming, is that it's got the same idea as functional programming, that you can really boil these functions down to explicitly what you need. And you can reuse them for that reason, too. We can even extend them with things like durable functions, where we can orchestrate many different functions at a time. So we really have just that encapsulation of what we are trying to accomplish when that event is run. And something that I also quite like is the principle of least power, which in computer programming is generally the idea, and Tim Berners-Lee talks about this a lot, is using the least powerful premise for any given operation, which can be a very, very powerful way of thinking about how to run these architectures. So we mentioned before that serverless can mean functions as a service, and there are a lot of other as-a-service things out there. So let's do a quick comparison of how you manage each of these services, just to clear up any confusion. So here's services and what they manage. And you can see hardware, infrastructure as a service. We've got hardware, platform as a service. And then finally, functions as a service is way up at the top. We're really only dealing with the application logic at that point. And that is a primary difference between some of the other offerings that you're given. This is an actual SVG animation, so if you want to check out the code, the link is there, and I'll share it later. Now, when we usually deploy server-side software, we start with a host instance, and then we deploy the application within the host. In a serverless paradigm, we remove both and replace it with a vendor fast platform that we don't manage ourselves. So we'll deploy these functions to this platform. And this allows us to just focus on the logic written as individual functions. So unlike the other earlier host and application model, this function isn't continuously running. When an event is triggered, the function is executed by the vendor in the container. And you might have seen this sticker before, right? There's no cloud. It's just someone else's computer. I think it's very popular. We can also extend this to, there's no serverless. It's just someone else's fully managed execution environment that I only pay a fraction of a second for whenever my function is run. So does this mean that we should serverless all the things? No, not really. Serverless is really good for a number of use cases, a bunch of which we're going to go over today. But it doesn't really do well with long-running stuff. So you can talk about something like WebSockets, or something like multiplayer online games, or real-time social upstream, or little stock tickers, or anything like that. Anything where we have these persistent connections, that's not exactly the perfect use case for something like serverless. So what is it good for? We have a number of examples today. We could clean data on a cron job. We could do things like take data and analyze the data and clean it up and use it for data visualizations, which we're going to do today. We can take it and create APIs with it, or use APIs with it. And we can crop images and upload it to the server using creating a user profile. I think that's the kind of the canonical example, so I'm not going to do that today. You've probably seen that example before. I'm going to do some other stuff. So, okay, setting up a function is pretty trivial. When we get a free account, we'll go into the portal like this. And I'm going to use Azure because I work for Microsoft, but this is similar in a lot of different applications and cloud providers. And we have a number of options that kind of get populated for us. So one thing I like to point out here is, oh man, I'm just learning Keynote, and I just love these transitions. The fire has nothing to do with anything at all. I'm just like, wow, fire. That consumption plan is really what we want, because the consumption plan is going to be the one that really auto-scales for us. There's another option here called App Service Plan, but then you'd have to manage the server a little bit more. So not quite what we were talking about with all the auto-scaling before it. So these are all the defaults. We can say validation successful, pin it to the dashboard, and here we go. We have a serverless function. So right away, they set us up with a test, which I've simplified and modified to include tacos, which is very important. It's a very important technical detail. You can see here that I'm including the name in the request body, which is delicious tacos. And I also have this context log. Oh, I have the context.res, which is pointing to that res rec.body.name. I also have this context log that's basically going to use, if you're not familiar with this kind of working with functions, context log is very similar to the console log if you're a JavaScript developer. So I'm going to be able to log with that yo, yo, yo. And if I run the function, you can see the output on the bottom right is hello delicious tacos, and then in my logs you can see that yo, 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 yo. So you can see both the ways that I can check and validate things and validate errors, and also how you're passing parameters and doing all of the normal things that you run a function. This is really exciting. This is not so far off from other types of application development, which means that you're not really context shifting that much to work with the server. So now we've set up a function. You know how to set up a function and run it. That was pretty cheap and easy, right? We did it really fast. So we already know how to write those functions. Let's apply it to a really common use case. And our first common use case is using Vue, Stripe, and Serverless to set up an e-commerce site. So we're just going to do a normal shop, set up the whole shop, and then also set up any kind of payment methods. And we can do this very, very quickly. So here's a sample Vue application that I made. There comes a time in any young app's life when it needs to monetize. And surely the way to make that process a little bit more direct is to accept payments, right? The sooner that you're accepting money on the front end, the sooner that you're actually going to be able to say, hey, we make money. So here we've got a shop, we've got a bunch of goodies, we've got our cart flow, and then you can see the serverless function execute. All of the code for this, all of the application code and all of the serverless function code is all on open source on GitHub. So if you want to stand it up yourself and play around with it and try it out, it's all available to you afterwards. So since we don't have the time to go through every single piece of the application, I'm giving you a bird's eye view of the structure so that you can see how it's all set up. So I'm using Nuxt and NextViewX. If you're not familiar with those things, those are very like Vue kind of terms. Nuxt is kind of like Next for Next and React are kind of sisters, and Nuxt and Vue are kind of sisters. Nuxt allows us some server-side rendering, code splitting. It's very performant. It also allows us to use Vue.js components as actual pages in the directories, so it's going to create routing for us. So basically, it'll give us a base layout. All of those pages that you see in there are just individual components that then become pages and then become routed. And all of the components there are also pieces of those pages. The Vuex store is our centralized state management. If you're familiar with Redux or something like that, to that nature, it holds all of our state to kind of disseminate through the application. You can also see that we have the serverless function and we have Stripe. We have this green bit of the serverless function. That's because we have a dependency in that serverless function on Stripe as well. And I'll show you how we do that. Let's start with Stripe because it's kind of the easiest to set up. It's just a couple of quick clicks. It's our lowest hanging fruit. We'll start there and kind of move forward. So you create your account, and then once you confirm, you can go to the sidebar in the dashboard and click API, and this will show you your testing keys right away. So it's all set up for you right away. So when you visit the Stripe documentation, the code that they give us to execute on the server expects the use of Express. You would create our customer and pass in the Stripe charges and the amount and some details. But where we're going, we don't need Express. We're already on the server. So how about that? We can eliminate a lot of this code and make things really, really slim and very, very executable. Okay, so this is great. Let's go through what we would do to make this work within the serverless function. So we'll add in our testing Stripe key, and then that module.exports is what we'll do to kick off a serverless function. That would change if we're using other cloud providers. That's what we use in Azure. So here we have the testing Stripe key and the module.exports. And then you can see we're still creating the customer with their email and token, just the way that you saw before. And we're passing in the amount and the details. And then we'll finish everything up and provide some error logs. And you'll note that I log a lot, and that's because I really want to make sure that if anything goes wrong, I know which step things go wrong in. That's a personal approach. You don't have to do it that way. So I like finding exactly where I'm at in that. So now when we execute our function, Here we go. Yes. In the test panel, we'll pass in what we're eventually going to get from the client, so a testing token, an email, some base charges, and you can also see all of those context logs printing, showing what our function did. So we have starting Stripe charges, finishing Stripe charges. And now we can see it was a success. We go back into the Stripe dashboard and we see the testing function is actually firing. We've got some payments coming through, some fake payments coming through, and it communicated with Stripe. There's one piece that we don't have time to cover today, and that's how we hook it all up with GitHub. But I have a post on CSS Tricks that goes through that entire process if you want to learn more. It's not actually that long to get everything set up in GitHub as well. So you don't have to run functions directly in the portal. You can have your normal build. And actually, Azure, if you're working with VS Code, there's a really, really nice Azure function extension that you can be working with. It helps with local debugging. So we've got all one side all done. Now we've got to connect things between our serverless function and our app. So first we're going to talk about that VueX store and our cart.vue page. So this big VueX store and the cart.vue page. All of our products are in a big manifest object in our VueX store. So you can see all of these things beneath are actually things that we're seeing in the Vue dev tools. So if you haven't used Vue before, they have certain dev tools that you can see to not only, the normal Chrome dev tool shows you the DOM, the Vue dev tool shows you the virtual DOM and the state that you're holding and how it's being manipulated. And that works across centralized state management stores too. So you can see here I added objects, and you can see our Vue.js store updates as well. So here's the shape of what we're going to begin building on that cart.vue page. First, if there are items in the cart, we'll add to our checkout component. Then if the cart is empty, we are going to give them the ability to go back to the main page and add items. And finally, if there's a success, we'll let people know it's being processed, and we'll show a success component. So let's look into that first code block. We have some items in our cart. We'll show a cart that reminds people of the items with a thumbnail, its quantity, and its price. And here's what that will look like. We'll get the total by getting the values from our cart and creating a computed value here. But now we're showing what's in the cart. We've got to build out that actual checkout form so that they can purchase what's there. So here's what we'll eventually have. That cart and a place to hold your email and your credit card. And the easiest possible way to do this is a component called Vue Stripe Checkout. I've linked it up to the repo here. It's literally a button that will call Stripe in the Stripe modal. It's really easy to implement. It's super great, except you might have noticed we didn't do that, right? We didn't have like a tiny little button. We actually integrated it fully with the site so that the credit card and checkout process looked like it was part of the app. So we can't use this. What we ended up using was a thing called Stripe Elements. The checkout form was embedded into the page and styled like the rest of the app. Then we can also do things like run tests, do form validations, all of those kind of things that actually in real production environments you'd really want to do. So they're a little bit more work to implement, but they allow you the freedom of handling the form yourself and making it fully integrated with your site. And there's a version called Vue Stripe Elements Plus. I tested out a number of these, and I found this one to be the most, kind of easiest to work with, but also the most involved on a level of like I can add the details that I want. I can add testing and things like that. So now we're going to go over that cart.vue page and how it relates to the checkout.vue component. So out of the box, the Vue Stripe Element Plus component gives you a few defaults. A couple of notable things here. You would put your Stripe key in the card component, and this button here has a pay method that's attached to the click event. So as soon as you click that button, we're going to execute that pay method. And in the script in the same component, we have some imports. You can see at the bottom here that pay method. The create token returns a promise, which resolves in an object with a token or error key. So to configure it for our needs, we're going to need to store some data properties, including whether it was submitted, whether it was completed, the status, and the response. We'll also need to gather a bit of information from the cart.vue component, which was the parent. So we'll need the total that was in the cart as well as the success. So when someone clicks that form button, it kicks off that really important pay method where we have the create token promise, but we've also changed submitted to true, and we're using Axios to post a URL to our serverless function and send the email that collected the form, our token, and the total. And you might be wondering where I got that URL that I just posted to. Like, that was kind of magic, right? Well, when we first ran that function up here, here's that kind of portal view that you saw earlier. Right in the right-hand corner, there's the get function URL. That's what I'm going to use Axios to talk to right away. So after that's complete, we'll change the status to success. We'll clear the cart with a mutation in VueX, and we're going to log any errors. So to review, because this is a really important part, that pay method, I'm talking about the pay method over and over again, but this is really where all of the magic happens. So let's review that pay method really quickly. The pay method uses Axios to post our function to the function URL. It tracks whether we've submitted the form or not with this.submitted. It sends the email, token, and total. As you recall, that's what we needed for the serverless function to the serverless function. If it's successful, it commits to our VueX store. Mutation clears the cart, emits to the parent cart component that the payment was successful. And if it errors, it changes the status to failure and logs the error response for help with debugging. So while the function works its magic, we're going to show them this loader that's a few seconds long. And it has enough going on to kind of draw their attention, which reduces the perceived wait time. Now, if you don't know what perceived wait time is, I have a whole nother talk that's just about that. But the way that we log, how long things take actually isn't the way that human brains associate that time. Humans will think that time goes at least 33% faster than or slower than it does. So if you show them nothing, they're going to think that things are going way slower than what you're seeing in your console. If you give them something to watch and something to do in that time, they'll perceive it as way shorter. So it's very important to show some sort of loading screen while all of this is happening and we communicate with the server. In case of failure, oh, I feel so bad for this cat. I don't know who put him there. We'll let them know that something didn't quite work right, and we'll clear out anything set by the payment method, but we don't want to clear out the cart because we're going to let them try again. Because chances are something failed in some of the communication process. We still have everything in the cart. We can still send things through. In the case of success, good job, statue. We'll show them a little success animation that gets that dopamine flowing, and we're going to wait a little bit, but we're going to reset the cart so that they can continue shopping when they want to buy more items. So here's where we are now. That success is actually a component on its own, and it's still attached to the cart page. And it looks like this. I made a CodePen demo for you if you want to check out the code, and we create a set timeout event, restart the cart with a function on the parent emitted from here. So basically, if you're not familiar with Vue.js or React.js because they work the same way, basically we have props and events down, and then we emit back up. We're basically always sending things down, and we're going to emit to talk to the parent. Okay, so remember this view? We have the cart total, we'll add our empty state, and we're going to add our success. So here's what we have. We created our cart and imported our checkout component that tracks a successful payment. If the cart was empty, we let them fill it up by going back to the home page. And if the payment was successful, we show a success component, restart the cart on a set timeout, clearing out what we have. You did it, party. In 15 minutes, you set up an entire shop application from start to finish. You did the entire application, you did the entire Stripe bit, you did the entire serverless function, and now you can create an e-commerce site to sell all of your horrible t-shirts that are laying in your closet at home. Perfect. Okay. Let's go over another really common use case. So we're going to create our own API this time. Last time we were using Stripe's API, which is totally cool because Stripe's API is super rad, especially for accepting payments online. And they've done a lot of really good work in that space. But what if you want something a little bit more unique and you want to do your own API? Serverless Functions makes this so really so incredibly simple. There's a ton of steps that you don't have to go through that we're kind of used to traditionally going through when we make our own API that you can kind of circumvent when you create a serverless API. So here's our application. I wanted to make an app where I could explore cocktails. This is the initial version with some simple search and random functionality, but soon I'm going to make it so that you can just input ingredients from your fridge, and then it will tell you what cocktail you are able to make from the random ingredients you have around. But then I was thinking that not everybody drinks and likes cocktails, and that's not very inclusive. Maybe there are people who don't drink in the audience and they still want to make these applications. So I could make something like an ice cream finder, and that would be a little bit more inclusive. But then I was just thinking, well, some people are lactose intolerant, and some people don't like ice cream, so that's not really totally inclusive either. So maybe people don't like sugar, that's the thing. So maybe I would make a puppy finder. But then I was thinking, I like puppies, but not everybody likes puppies. Some people are cat people, and some people are allergic to puppies, and I have a friend who's scared of puppies, unfortunately. So maybe we could just, broaden it even more, and we can make a things we like finder. and then it can be really for everybody. That's a very complex UX to build, actually. And it has a lot of parameters, which is kind of difficult to demo. So I'm going to show it with the cocktail finder, because that's what I like. But just know that this type of application can be used for anything you like: puppies, ice cream, kittens, anything you like in the world. And it's all manners of liking things application. All right. So the first thing we're going to do is we're going to make our serverless function. You guys are like old hats at this. You're like, all right, I already know how to make one of those. That's no big deal. And so then we can come in here, and as soon as we make our function, we'll go into integrate, which is the second on right after the trigger. So we take our selected methods. We're really going to unclick all of those and just use get for this. We also made a root template that said hello, and our authorization level is anonymous. Because I went through that really quickly, let's go over it one more time. In integrate, we gave the root template a name, a specific name that we want. We set the authorization level to anonymous. We changed it to allowed HTTP methods, and in there we selected get. So what this does is it allows me to say, go to the URL for my function, which we got from that get function URL you saw earlier. And we're saying API hello, and then I'm basically querying for Taco Face, which is my name. And it says, hello, Sarah, Taco Face. So there we go. We have the Taco Face query. So that was all we needed. Those few clicks were all we needed to start creating an API that we can surface and an API that we can use. I think that's fascinating. That's so cool. So perfect is the enemy of good, and in this case, my app is neither perfect nor good, so I'm still futzing with it. So I'm going to show you some sample data instead of the real thing, which is a giant thing. I'm going to show you a smaller amount of data. But basically what I'm going to do is I'm going to take all of my data, and I'm going to store it in Cosmos DB. And you don't need to use Cosmos DB. It will work literally for any database. But Cosmos DB and Azure Functions are both under Azure, so it's actually a really quick integration, and I'll show you how that works. So I'm going to store it in Cosmos DB. It's going to be surfaced by my serverless function so that we're not accessing it directly the way that you do with an API, and then we can use it in an application. So here, we're going to add our database, which is going to be Cocktail Finder. We're going to add our collection, which is going to be cocktails. Our partition key is going to be ID. That's actually what they suggest. So we're just going to do what they're suggesting. And here we go. So here, I create a Cosmos database and collection where where the documents are each drink. And I'm showing you 3 here, like I mentioned, as a sample. So anything without an underscore in here are things that I've manually added myself. I've decided what glass people are using. I've decided what ingredients people are using. I've given them directions. But anything with the underscored keys are things that Cosmos DB is bringing in as soon as I process that document. It's like, you're going to need this other stuff. So that's stuff that's generated from Cosmos. So now I'm going to go back to that serverless function. And again, in integrate, we saw integrate before. we go into the Integrate tab, and we click Inputs, and we get all of these kind of options here. And now you can see why I would pick something like Cosmos DB. It's super easy to integrate, right? I'm just clicking Azure Cosmos DB there, clicking Select, and then it gets set up for me. So in my function.json, here's what I start off with. Here's the defaults. And then I'm going to add some new things into this to connect both of them. Now, type, name, if you're looking at this, actually, I'm going to zoom in on this one part. Type, name, direction, and connection are all given to me. Those are all the defaults. But what I have to write in are things like the database name, which we said was Cocktail Finder, the collection name, which I said was cocktails, the partition key, which we talked about being ID, and so the rest of them are default. So that will create the connection between these two things. And I want you to pay particular note to that name there. We have input document as the name. We're going to use that in just a second. So here's what we start off with when we work with our serverless function. When we first get our serverless function, it's going to say, oh, you need an HTTP trigger. Here's some boilerplate code for you. So this is what we start off with, and here's where we go with it. We basically see if we have context.bindings. Again, I log a lot, so context.log, get ready. In context.res, we're setting that to the status, which is 200, and then the body is going to be context.bindings.input document. That was the thing that we said in that name field, right? That needs to be connected to the two of them. So now we can go in here, and we can see over in our JSON, all of those things are updated, and we've stored them. That's how we get to it. In an index.js, you see the function we created. We're going to run that. You can see the status is OK, and we've also outputted it here, so you can see all of that Cosmos DB data just kind of coming in, and now we have that access to that as our API. So what does this look like on a front end that's communicating with it? This is a small amount of code to be able to communicate with that Cosmos DB API that we created. All I'm doing is I'm creating a new Vue app, so that's a new Vue instance. I'm connecting that EL is connecting div ID app, which is basically saying, go get that div ID app. That's going to be a part of that Vue instance. In the data, I'm saying info is null because I'm going to set that in just a second when I go into created lifecycle method, use Axios to go to that API, and then I set the response to this.info. And now you can see I'm dumping all of this JSON data into the page. But it's just to show that that's not that much code in any of them, actually. We didn't do that much between Cosmos DB, the serverless function, or in Vue.js to start to get this really, really nice, clean exchange between our data and a way that we can output it. So this is like a really big success. I mean, let's talk about it for a second because it's really important. In a non-serverless paradigm, we have to pick something like Express. We have to set up endpoints. You have to give your web server access to the database server. You have to deploy it. And we created an API with serverless functions with a few button clicks and just a few modifications. So that's a really big deal. Now we have the super fun part where we're using that data to output to the page, and we can make our app however we want it to be. Sky's the limit for what we can create now. So so we're going to talk about that page right here, and then we're going to talk about this component. And the page is item.view. So anytime I show one of the cocktails, one of the items here, I'm basically doing the same thing that we saw in that CodePen demo, where we've got the created lifecycle method. We go to this.axios. We get to our function URL, and then we're going to change it to the response.body. And then we're going to output it onto the page. So the components in app.drinkSingle.view, we are basically going to go through and create the info for the drink and all of the ingredients and all of the mixtures and details. And now people can make beautiful cocktails or puppies or ice cream or things we like, right? So anything that you want to create with this data, sky's the limits. So this is what we get, a nice API to traverse and create APIs that are for building for people that like things. And I like cocktails. So, okay, last thing that we're going to do today. In the time that we have left, let's do one more thing. I mentioned earlier that we can have a serverless function fetch data for beautiful front-end data visualizations powered by Vue, so let's do that next. As I mentioned before, I work for Microsoft as a developer advocate, and people often ask me where my team is speaking and when, because we're kind of all over the world all the time. So I made this demo with Vue.JS, a globe library, and serverless functions so that people can explore where we're at. So here I'm executing a serverless function to gather all of the geolocation data for the pins on these globes based on where we're speaking and how much we're speaking. So the pins get longer for the frequency. And I'm not going to go into a huge amount of technical detail for this one in particular, but anything that I don't cover today is in the CSS tricks article below, and all of the repos are open source, the function and the code for the application. So what we start off with is this. After spending many weeks trying to get all my coworkers to fill out all of the places that they're going to be around the world, which is no small task, it's the most difficult part of this application is gathering all of the data. We have this Excel spreadsheet where I can export a CSV or JSON file where I have information like this. So this is one piece of it. This is Simona. She was in Tel Aviv. So I have the location that's Tel Aviv, right? But the globe data doesn't care about names like Tel Aviv. What I need to give it is latitude and longitude. So here's what I have, and I'm going to store that in NextViewX, which is our central state management store. I'm going to make a function, and before we've been using HTTP triggers, but there's a number of things that we can use serverless functions for. I'm going to use a GitHub Webhook, and this is really valuable if you want something to execute every time you push to master. This is a really, really good one to use. So you already kind of know how this all works. You kind of know how to create those functions and what they all look like. So once I have that function, that's the GitHub Webhook, I'm going to connect it to the repo that I need to use it with. And then we're going to retrieve geo information for each item in the original data. So we're basically going to go through and we're going to use the Google Maps API and grab the name of the location and figure out what the latitude and longitude is. And what not shown here, we're going to error if it doesn't go well. But you've already seen that I log a lot about with the errors. Okay, so great. Given an array of entries wrapped in an iterator, we're going to walk through each one of them and populate latitude and longitude using that Google Maps API. And note, we're also going to cache locations to try to save some API calls. So after this, we'll check the cache and see if we've already looked up this location as well. Now you can see our function at work. It's taking all of the locations in our GitHub file in GitHub, and it's going to change the locations. It's basically going to take the locations and then add a few more properties. So we've got we have it updating with all of the cached Atlanta, and then Amsterdam. It's plotting new coordinates for each one of those. And so those all get added to our VueX store. So directly inside of our GitHub repo where we're going to need them. So we can use this for the table and the globe. So anytime we update the file, committing to master, the function will be triggered, and it'll update the file like this. And we can be lazy programmers. We can just have that do all of that information for us so that we can just pull that directly into our VueX store. So remember when I showed you that first demo, how people were typing into the table and it was filtering through that table really quickly as we were like changing whether it was the name or the conference. The way that we do this, and this is very Vue.js based, not serverless based, is by use of a computed property in Vue. And computed properties in Vue are so powerful because they're basically some logic that's cached based on its dependencies, and it won't be rerun unless something changes. So it will only update when it's needed, and it kind of looks like a method. Like in Vue and other applications, we have methods that look like this, and it's used kind of the same way, except that that speaker data and that filter data is actually used more like data, where we can actually bring it to be present inside of our application application. And the logic will be run anytime something filters. So let's check this out. When I put it inside the actual markup of this, you can see in the table, I'm using that filtered data. I'm not using data from the table itself. I'm using the filtered data to run through that process. And now you can see it in action. I'm writing the conference, and you can see how fast that is. Like, it's very, very difficult to get that kind of filtration so quickly on the client side. And this is a really, really performant way of doing so. So computed properties in Vue, if you have a lot of data, you're working with a lot of data from serverless, this is a really important part that you shouldn't miss out on. You should read up more on. And as you might have noticed on our globe, we need a pin for each latitude and longitude, but that's not all we're doing. We're going to make it longer for repeat instances. So we'll check if the location already exists, and if it does, we're going to increment it. And if not, we're going to create new values for them. We'll use the data in this format, and we're going to feed it into our globe visualization. And yeah, there's information about arm wrestling me on that slide if you saw it. To work with Vue.JS, we mounted into the DOM on a single element. The code to create the globe is pretty large, so in order to keep things readable in the component, I'm using a thing called a Mixin here. That's kind of a nice way to keep it separate from all the other logic from the component, and also so that I can keep it reusable. So I'm trying to keep it very modular by instantiating that in a Mixin. And I'm going to call pieces of that Mixin in mounted, but you might also notice one extra thing. So if you do decide to do data visualizations with Vue.JS, if you're loading textures, what I've found to be the most performant way is that if you load the textures first and then pass them into the function. And that tends to make it perform just, some microseconds faster, but microseconds are important as well. So that's just like a little tip that I've noticed while I was working with it. Ooh. And not that you'd want to do this, but because Vue and Vue.js play so nicely together, we can update the appearance of this globe by just changing a line of code. So this one line of code can change it from a sphere to an icosahedron. I could have used like a torus knot. Don't do that with your globes. But I'm just trying to say that it just takes one line of code to completely change any of these data visualizations and have them be manipulatable, that's not a word, in three-dimensional space. So we can create myriad projects with Vue and Vue.js, in the world of data visualization is our oyster. Serverless and Vue allow us to accomplish a lot without a lot of infrastructure. It's so cool how these technologies can play so well together and accomplish so many tasks so quickly. I hope this gets you set up pairing Vue and serverless functions to make beautiful applications on the web. Come see me if you have any questions after this talk. Thank you.